All right, good afternoon. It's great to be here. It almost feels like a family. I think we are the like-minded people who are excited about CXL. So I, for one, is a fan of CXL. So it's Charles' fan here. I think this morning we heard from a bunch of hardware vendors, from the processors to memory. And this afternoon, we're going to go into the software side. MemVerge started about 5 years ago. And since that day, we've been dreaming for a day like this, when something as wonderful as CXL is finally ready to take off. In fact, this week, CXL 3.0 got published. And I think that, I think that's a very significant milestone. And we also heard, a number of new devices is coming to market. In fact, at 4 o'clock, I think right about now, as the exhibit opens, you'll see a number of CXL devices on display, both at the MemVerge booth as well as the other vendor booth. So it's finally come about. But why? Why do we need these new kind of memory devices? The driver started from the applications. Over the last 10 years, we are seeing many new modern applications emerging from AI, machine learning, big data analytics, et cetera, that are dealing with more and more data at faster and faster speed. And this is going beyond what a traditional storage system could handle. And they just cannot have enough memory. Their demand for the capacity, bandwidth, as well as latency that only a memory-centric system could provide. And until now, we really been constrained in the memory space in terms of scale, both in terms of capacity and bandwidth. And we believe CXL is a key technology that can open the door to a memory infrastructure that is abundant, both in capacity and performance, that is composable, that can be pooled and dynamically provisioned to computing instances. And we believe it could be available as well, that memory can be made to persist as well as to replicate. So these are the services that can potentially come because the arrival of CXL. If we go back to the history for about 30 years, maybe 32 years, storage went through the same transition. In the 80s or 70s, there's no storage industry. It is just a device that's inside of a computer. It's a hard drive. You buy a computer with a storage built inside. And then came about a new fabric, a fiber channel, that can externalize storage or disaggregate storage away from compute. And you can create a storage system or storage array that are independently scalable, manageable, and available. That brought the whole storage industry, the storage area network attached storage. It became a $100 billion market in the course of 20 years. And we believe we are facing a similar opportunity here, as vendors in this place, that there is no independent memory system industry today. I mean, there are memory devices that go inside of a computer that's being sold as a part of a computer, but there's no independent memory array, memory appliance, memory server, or memory pool that can be built either in hardware or in software today. And we believe that's going to change with the arrival of CXL. Essentially, it can disaggregate memory away from compute so that it becomes independent, and it can be independently scalable, independently managed, independently protected, and there will be software developed on top of CXL that are delivering these services that will bring about a pool of memory and eventually a memory as a service that can be made available to applications on demand. And this is the vision we started our journey trying to fulfill 5 years ago. And we are super excited now CXL is here that can help us fulfill this vision. Now, if we take a look at the pooled memory. So CXL, there will be steps. There will be crawl, walk, run stage. There will be CXL 1.1. Many of the devices being displayed today are 1.1 devices. And they are very good that can expand memory capacity inside a server. And then with 2.0, I think that's when where the real excitement start. It's where the memory can be disaggregated and pulled together. And this is a bit of a more hardware view in terms of what they will look like. So imagine that you'll have a rack where on the top of the rack, you'll have a switch. And with 2.0, you'll support one switch that can interconnect between your memory device and your computing hosts. And then you have a pool of memory that are assembled in some form that's made available to all the computing hosts. And then I have a pool manager there, which can also be called a fabric manager, that essentially help managing this pool of memory and at the same time talking to all the software components on all the hosts to coordinate between the hosts and the pool on the provisioning, on the data services, and on many other interesting features I'm going to go into. So this is a basic look of a disaggregated pooled memory system. It looks like hardware, but it could be made available as a software-defined product working out of off-the-shelf hardware solutions. And then with 3.0 that was announced this week, this can scale to multiple racks, multiple switches, where the scale of the compute and the scale of the memory can be further increased. So now let me go into a few interesting use cases where a pooled memory concept can be transformative to a data center. I'll give 3 examples. The first is a simple example. It's the easiest example people can see, but it represents billions of dollars where customers can save. And this is the dynamic memory expansion that can reduce the amount of stranded memory in a data center. There was a good paper that was published a few months ago in March of this year by Microsoft Azure team. And they did a study across the Azure data center, and they found over 40% of memory was never used in the data center, wasted. And at the same time, they also found more than 50% of the server cost actually memory cost. So that means 20% of overall server cost, there are millions of servers, are never being used, wasted. And these are billions of dollars that you can reclaim from that. And why are there so much memory wasted? It's because memory today are imprisoned inside of the server enclosure. So in the provisioning time, in the configuring time, you have to be pessimistic in terms of how much memory you want to include in each server. You have to prepare for the worst case. So each server are equipped with a lot of memory. So essentially you have half a terabyte of memory inside the server for the worst case. But in many of these servers, the worst case never happens. Many of these memories didn't get actually used. And that's the reason those are being stranded. Now with pooled memory, what you could do is you could have those memory to be available as part of a pool and have less memory provision per server. You know, I only drew 3 here, but you could have 15, 20, 32 servers here sharing a pool of memory. And only when the local memory is being exhausted, that's when you provision new memory from the pool. So in this case, the first and the third servers have enough memory for the VMs or the containers or the applications that are running on those servers. The middle one, the second server, ran out, and it provisioned a couple memory capacity units from the pool and to increase the memory capacity on demand. And by doing this, just from the Microsoft paper, they found out if they just increase the utilization by 10%, they can save many hundreds of millions of dollars per year just from Microsoft alone. And if you expand that to industry, that's billions of dollars you can save just by reducing the amount of stranded memory. And this applies to hyperscalers, this applies to enterprises as well. So that's the first use case. The second use case is also very interesting. And this is, I call memory auto-healing with transparent migration. So now let's assume there's a server and it is more aggressively provisioned, not too much memory. And as we know, as much of a smart algorithms, error correcting codes and so on, putting in the memory, they still fail sometimes, especially if you have hundreds of thousands of servers, that some memories do fail over time. But they do give out signals as they starting to fail, the error rate start to go up, and you can catch those signals. So with the right software and with the right pooled memory available, we can monitor faulty memories as they're starting to go bad, and we can provision a new memory from the pool. And with the right software, which I'm going to go into details, you can start a transparent migration of data from that memory that's going bad to the memory that's provisioned. And during all that, you don't have to touch the application. They can keep going. And after it's complete, the job carries on. Basically, you have auto-healed from a broken memory by using a good memory from your pool. So having the pool available gives you a dynamic ability to fix faults in your computing subsystems as well. So this is the second use case. Now the third example, I think, could be the most exciting and could represent the biggest opportunity. This is, by the way, Spark is just an example of the modern applications which are typically distributed. The reason they are distributed is because these applications are data intensive, they are also compute intensive. They require more cores than a single server could provide. So almost all modern applications can be horizontally scalable and can scale out. You can have many nodes using more processing power to process these data. But today, how it's being done, because there's no CXL or no shared memory system being available, the typical way it's being done is that the intermediate data from these computation are being saved to local storage, local SSDs. And this incurs the typical storage I/O, the serialization, deserialization, and all the latencies you need to save them onto the local storage. And after a particular stage of computation is finished, you go through a shuffling or a kind of scatter and gather stage where the intermediate data is being exchanged between these computation nodes. So they are ready for the next stage of computation because they need to cross-access these data for the next stage of processing. And this is a very common pattern across a lot of these application workloads. And often these shuffling stage are the most time-consuming part of running the job. You spend hours and hours doing these data exchanges because it incurs both storage I/O and network I/O as you are doing this. Now, with CXL 3.0, having the cache coherency and between multiple nodes, you can really enable not only pooled memory, but potentially shared memory as well. So instead of saving them onto the local SSDs and incurring network latency and the time to doing the shuffling, you could using a shared memory to save these intermediate data and for each node just directly access these data without shuffle them across multiple nodes. And this would dramatically reduce the running time of these modern workloads and give you much faster time to results, which are critical to many of the enterprises that are running this. So those are just three examples of how CXL-based memory systems could potentially offer value to the customers from service providers to the enterprises. Now, hardware is the foundation of making these happen, but it is far from sufficient. There need to be software subsystems to be created to make the scenarios I described earlier possible. And this, by the way, is a journey that MemVerge has been on for the last 5 years, that we foresee a future in a shared a big memory future. And we are identifying the right software components that need to be created to make this possible. As we mentioned, there are a lot of similarities between memory and storage, including the need of software. But there are some differences as well. Now, one key difference is with memory, because how close it is to the actual application, and the knowledge that's required to the running processes of the application. For memory, the amount of software that's needed on the host is more than those required by storage. So we actually started from the host side in terms of what's needed, what's the software needed to enable the memory, big memory. So in here, we have 3 software components drawn. On the left-hand side are the computing hosts. And the first component we call memory machine, and this is our product. There could be other product does similar things. It's basically include a virtualization engine that can creating a mapping between the software-defined memory the application sees to the actual physical memory tiers that are being available on the system. And then it laid various data services on top of it. Start with tiering, as we heard from VMware, from other vendors. Tiering is often a good starting point when you need the application to transparently use a heterogeneous memory without changing the application, that you need an intelligent and transparent tiering mechanism. And that is what Memory Machine delivered for the last 2 years. Then we added a service called in-memory snapshot. This provides a first-level protection of a running application, including all the memory state, the CPU cache, as well as the operating system state, that allow this application to be protected and to be restored anytime, anywhere. So it's an efficient mechanism where we can capture the memory state, taking advantage of our virtualization engine to achieve the protection and potentially migration mobility of the application. And this is the component between tiering and the virtualization engine and the snapshotting is what we can enable the transparent migration I mentioned in the use case 2, when you have a faulty memory unit to perform the migration. And to enable memory sharing, at least during the first few years, we believe there are software capabilities that need to be implemented to enable the applications to enjoy the capability that CXL devices provide, to allow all the cache management to be done correctly across the working nodes so that they can share data across shared memory without conflict. So those are the other components of Memory Machine. And then Memory Viewer also is another important component that does 2 important things. One is it can help monitor the health, the capacity, and the performance of the memory units. And second, it can help profile the performance of the applications. And then on the memory side, on the fabric and pool side, there also need to be software that's running on the pool manager that does a number of important functions as well, starting from provisioning. It needs to manage the dynamic provisioning of the memory units on the pool, and eventually perhaps thin provisioning of the memory that's made available to the computing hosts. And it can have interesting capabilities to reduce the amount of physical memory it needs in terms of reduction of raw capacity through compression or deduplication. It can add capabilities to protect data on the pool side, to add security features, and it can also help monitor the running workload by talking to the hosts and to be able to dynamically schedule memory in a more intelligent way. So it requires software both on the host side and the pool side to run well on top of CXL infrastructure to enable this new world. Okay, so that's a vision. Not everything on this picture is available today. So now let me tell you what's available today. In fact, this week we made 2 very exciting announcements. The first announcement is that we are announcing a new version of Memory Machine called Memory Machine Cloud Edition. As I mentioned, Memory Machine has been on the market for 2 years, and it has really good support for Intel Optane memory over the last 2 years because it's doing tiering and doing snapshotting. As we have heard, that Intel have end of life or winding down the Optane memory units. And now, obviously we have been expecting this. So over the last year, we have evolved the technology so that number one, it supports well the DRAM-only environment. Number two, it supports well the cloud environment. It has some compelling use cases in the cloud where it can allow you to use spot instances for your long-running workload without worrying being preempted by the cloud service providers, because we have snapshot that can protect your applications. If your VMs go away, we can provision a new VM and continue running your application from the snapshot. And in effect, this can save customers up to 70% of their cloud running cost. And this is a version of product that delivers that. It can run on DRAM only, it can run on cloud, and it can deliver the cloud cost savings, and that's the MemVerge Cloud Edition. What you will see in the MemVerge booth is actually a montage card at work. And this is a number that you'll see, like Chris mentioned, it's about 95% of the DDR5 DRAM performance. So we ran the MLC benchmark, and we ran the Steam benchmark, where the blue bar are the DDR, the orange bar is the montage CXL card performance, and the gray bar is the combination of the auto-tiering with the MemVerge software. So you'll see the performance of DDR and the CXL is very close, and this is actually a real product at work, and where the auto-tiering can make them even faster. Again, live demo, booth 1040, and welcome. All right. The second component is a memory viewer product, and this is actually a new product that we are announcing today. And this can help you monitor all the memory system that's plugged into your system, and when a CXL memory is officially shipped, this is going to support all the CXL memory component as well. You can see the capacity, you can see the configuration, you can see the performance into each of the memory modules or each of the CPU sockets. And what's more, it can also help monitor the application performance. It can monitor for each application to see how much memory you have allocated and how much of the memory are being actively allocated, actively accessed in this period of time. So this can tell you, how utilized your allocated memory are, and can inform you on the right configuration on the tiering. Whether this is a suitable application to add a slower tier of memory, and what's the right ratio between faster tier of memory and slower tier memory you should have. And one benefit of memory machine tiering is that you can dynamically change the ratio between two tiers of memory. So that gives you the best trade-off between cost and performance. And this product is available today, and it's free. It's a freely downloadable, freely used, and you can immediately gain better visibility into your memory infrastructure. So those are the, I think this is my last slide. Essentially, I've tried to share a vision of CXL that's very exciting, and that we are starting to deliver the software stack that's needed to enable this vision by working with the entire ecosystem of CXL vendors. And many of them are represented here at this forum, and it's our honor to co-host this with the CXL consortium here. I think we are hearing from many of the memory device vendors as well as system vendors, and also the processors vendors. And I think we are starting to see the emerging group of companies that are creating the CXL switches. That's a new fabric that's being created to interconnect memory and processing. And the server vendors are coming along as well. That among the virtual sessions that you will see on the website, you'll hear some of these server vendors as they start to embracing the CXL also. And we are hearing from some of the hyperscalers, cloud service providers, that they are start looking closely into CXL, how this can help improve their infrastructure and the service they can deliver to their customers. And you will hear from the users and application developers as well, last but not least, all the standards bodies. So I think we are seeing a tremendous momentum behind CXL, and we want to do our little part to bring this into reality. Thank you.